1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, around 20 odd people. Is there anyone else who would like to raise their hands? Please do so. This could be any form of introduction that you had uh, in your engineering graduations, or you could have attended any boot camp sessions or anything of that sort. Okay, all right, cool. That's nice. So how many of you, maybe you can lower your hands. All of you can lower your hands. Okay. So my next question is, how many of you are aware of AWS Cloud? One, two, three, four, five, six. Okay, so far 6 of you. Anyone else who has got some introduction to AWS Cloud or have worked with AWS Cloud, implemented it as a POC, implemented it uh, as a small fun project, or have worked on any real-time projects with AWS? Okay, so I will take it as 6. Okay, sure. Thanks for that short survey. So let's get started. So we have about 1/3, right? Or not even 1/3, 1/4 of the class, who have raised their hand saying that they are aware of what cloud is, or they've been introduced to cloud in some form or shape. And about 6 of you who have raised your hand saying that you are aware of AWS in some form or shape, right? So don't worry. I mean, we are here to, increase your proficiency levels for the rest of you, or even those who raise your hands. Our motto is to increase your proficiency levels over the next few weeks and ensure that you gain a decent knowledge on cloud and on AWS, right? So to the extent of putting your hands on the keyboard, and to the extent of using that skill to demonstrate as part of your career aspirations, right? And I'm sure you will be able to navigate through your career aspirations well with these subsequent sessions. Uh, but given that there are 2 requests from my side. One, uh, let's all demonstrate a good amount of good degree of discipline in terms of attending these classes over the next few weeks. Okay, and number 2, if you need help, please ask for it. And if you're stuck with something while you're doing some assignments, and while you're reading something, and if you're stuck with something, so please reach out to your mentors, right? And we are here to help you out through this learning process, right? So this is a small submission from my side, just to ensure that the purpose of this is jointly met by all of us together. Okay, all right, cool. Let's get started. I just have a short presentation for today. So the agenda for today is going to be, I will introduce you into what is cloud, right? How the genesis of cloud, how did cloud computing start, right? And what are the various different dimensions and models of cloud computing, and then I'll give you some interesting anecdotes and things like that. That's the agenda for today for the next 40-45 minutes or so. But tomorrow, what we are going to do is I'm going to introduce you to the curriculum for the next few weeks for AWS, and I'm going to give you in-depth curriculum of what are the sessions that we are going to go through on a daily basis, and what you can expect out of it. So that way it will help all of us to plan it better. And I think there's some of your friends who are still missing in the classroom. I think slowly the numbers are increasing, but please ensure that you join this at sharp 8:57. Sorry, 7:50. Sorry, 8:57, 8:58, so that we can get started at 9 o'clock and we can maximize this 1 hour that we have at our disposal. This time is very important and is precious. Let's ensure that we all have that discipline, grow that degree of discipline, and then we will get started with the AWS hands-on portion shortly. Okay, all right. Yeah, please go on mute. Please don't unmute. Okay, let me just share my screen. I'll take you through a short presentation on what cloud is. Okay, so before I start, maybe let's spend about 2 to 3 minutes. People who said you're aware of cloud computing, can you briefly describe it in 15-20 seconds? Open for anyone to unmute and there are about 20 odd people who said you're aware of cloud.
Hello, sir. Good morning.
Yeah, good morning.
So we can say cloud computing is the technology that enables us to access our files or any sort of works remotely from anywhere.
Okay,
Like,
great.
for example, we have this cloud storage, Google Drive. Instead of when we save some files in our hard disk, in our laptop, but we don't have our laptop and we had to access this from somewhere else. When we store those in Google Drive, we can access them from anywhere with a quick access of internet.
Okay, great. Thanks. Thank you, SG55. Anyone else would like to take a shot at the definition?
Yes, sir. Good morning.
Yeah. Good morning.
Yes, sir. In cloud, we can use to store a large amount of data, and it is consisting of several servers. Several servers, and completely cloud is divided into 3 types. That is IaaS, PaaS, SaaS. IaaS means infrastructure as a service, PaaS means platform as a service, SaaS means software as a service. In platform as a service, completely based on database. I mean Cosmo DB and all. So the cloud is divided into these 3 types. In cloud, there are several like containers and Kubernetes also. In Kubernetes, the Kubernetes and containers, it is used to store a large amount of servers, and it is used to deploy the web applications via mobile applications also.
Okay.
Thank you, sir.
Great.
Thank you, sir.
Thank you. Thanks, SB20. All right. So, I mean, partially you're all right. Okay. But cloud is much more than that. I mean, it is used for storage, and it is used for hyperscales, and it is used for multiple things. But before we actually dive deeper into what is cloud, let's basically understand the history of cloud. Okay. So it was sometime in 1960s, right? John McCarthy thought that why can't computation be someday organized as a public utility? Okay. So now, what is a public utility? I mean, all of us know, right? I mean, all of us are using public utilities like mass transportation, such as buses, metros, trains, and so on and so forth. And the other common example of public utility is electricity, correct? I mean, this huge network of grids that supply electricity to cities, towns, villages, countries, right? And there are power organizations who generate power, right, and sell the power, right, on demand basis, right? The reason why I'm saying on demand is, we use on demand, and we pay for what we use. We pay for what we consume, correct? So this is a thought that came up, long back, right, in 1960s itself, that as to why can't it be organized as a public utility? So now the advantage of doing it as a public utility is multifold. We'll talk about it a bit later, right? So then came, while this thought was there in 1960s, but there was no technology that could support, support with the materialization of this thought, right? So then came in 1990s, the widespread usage of networks, right? So broad networks. I mean, earlier networks were very, very limited, right? So there was no internet in the early days, right? And the network was very, very limited to, so military and army used to have their own network, right? Which they used to call it as internet. The telecom companies and telecom industry was booming at that point in time, with landlines being there, right? With very limited capability to just transfer the voice data, right? So that's how. But later in 1990s is when, while the telecom sector was growing, and while the technology behind transferring data was increasing and was developing. So that's when telecom companies basically commercialized large networks by offering virtual private network. I'm sorry, somebody has to go on mute, please. By offering virtual private network, right? So even today, to this date, we use VPNs. Right? So VPN is a very common terminology, right? And but what they sorry, somebody is not on mute. Please go on mute. SG05. Yeah, I request people not to unmute, please. So that's the advancement that that kind of gave way to the internet, right? So the current world internet that we have, the current scenario internet that we have, is all this starts from 1990s, right? So that's when the telecom companies called it as Telecom Cloud. So that's where the term cloud came from. Okay, so where, if you see this diagram, you have a head office and you have regional offices, multiple offices. In fact, I still remember when I started my career, we had multiple branches, and there was a branch in the US, a head office in the US. We had multiple branches in India, and we used to take a leased line with one of the ISPs and connect our branches using VPN connections. Okay, of course, those days, 90s, it used to be so thin. The VPN connections used to be so unstable and thin, but of course, that gave us some, connectivity to connect our branch offices. So now this whole thing, they called it as MPLS, and eventually this became an MPLS, right? And then they called it as MPLS Cloud, right? So because all of this would go to the cloud, and it actually goes over the internet, gets connected, but it's a very secure tunnel between the head office and regional offices. And today, what we have is cloud computing, right? I mean, while this all started as a network, right, it was more for connecting multiple offices together using VPN connections with the network that the telecom companies had. But in today's world, this has evolved a lot more mature in terms of offering a whole suite of computing services on the cloud, right? So where users could go self-service, and users could just look at this kind of services that they need, and they could just go ahead and consume those services, right? So that's how the cloud computing today that we see has evolved over a period of time with a lot of innovation, with a lot of technology advancements, and of course, all of this have have grown at a very equal pace. And today we are able to see the technology delivered through the form of cloud computing. Okay, so now always remember, cloud computing is not just storage. It's not just standing up the Kubernetes servers on the AWS or Azure or Google, right? Or it is not just about one or two services. Cloud computing is a very broad terminology. Cloud computing gives you a broader set of services that consumers can use. Consumers can store data, consumers can process data, consumers can build applications on cloud, right? Consumers can build mobile applications on cloud, and they can use it with a broad network access. Okay, and they can have multiple different models for cloud. But why do we need cloud, right? I mean, why can't we just look at the traditional way of computing, right? If you see, this is how the whole cloud computing evolved over a period of time, right? In 1970s, there used to be, as I said, grid computing, where the telecom companies would offer these networks, and each branch office or each customer would actually connect to their subsidiaries or to their branch offices through that, right? So then in 1990s, web-based utility computing came up, right? So that is where, if you see, e-commerce was booming, right, in 1990s. In fact, Amazon started in 1990s, right? So, and e-commerce was booming, and usage of internet was really kicking off in those days, right? And also the dot-com burst, that kind of created so much of opportunities for businesses to rethink the way they deliver their services to consumers, right? So that's the reason why you see that in 1990s this whole dot-com burst came up, and a lot of organizations started building their own websites, web applications, and so on and so forth, using the programming languages that were there at that point in time, and even today pretty much they are there, right? But all of those were delivered using the internet facility that we had. Okay, and if you see, later in 2005, around that time, or 2006, SaaS computing became quite popular. SaaS is called software as a service. We are going to look at some of these models later, but SaaS computing became popular, and that's when there were subscription-based, usage-based models that came up, right? So where if you need an email service, you don't need to create your own email server, SMTP server, and host everything by yourself, right? You can just use a SaaS, software as a service, email service that is available publicly, like Gmail or Yahoo Mail and things like that, right? So that's when the SaaS computing became very popular, and then later in 2010, 2011, the actual cloud computing became so popular that it started offering multiple models, and enterprises started using cloud computing as their major lever to reduce cost and to increase their agility, and in order to make their businesses grow from a business outcome perspective, right? So that's where in 2011, 12 times, the adoption of cloud became so popular. In fact, 2006 is when AWS was started. Okay, Amazon Web Services was started in 2006. In fact, there are interesting videos around that which you can later listen to as to the evolution of how AWS came in. Initially, it was just only Amazon, where I'm sure all of you know what Amazon is. I don't have to explain. It started as a small online bookstore, and then it grew to such a massive volume, and it's kind of the e-commerce kingpin at this point in time, right? So then in 2006 is when Amazon thought, why don't we look at offering a cloud computing service, right, as a web service, right? Initially, that's how the web service came into the Amazon, right? Amazon Web Services, right, as a bunch of web services which can be accessed over internet. I mean, there's no special connectivity which is required. There's no special setup which is required to access the cloud, access the AWS. So that's the reason why the web services was associated with the AWS cloud platform. Okay, so that's when this whole adoption started. And today, if you see, pretty much every organization, every enterprise has got some portion of their workloads. So when I say workloads, it is their applications, right? It could be anything, right? It could be a web application, it could be a data processing application, right? It could be anything, right, that you see. So these are some of the terminologies that I'm going to use going forward. So I mean, if you have doubts, please clarify them early on. So workload, when I say workload is anything. It's like a payload, right? I mean, if all of you follow the satellite launches, right, through the rockets, what the standard terminology that they say is that a payload. So payload is the one which gets launched in the orbit through a particular type of rocket, right? And each rocket has got its own limitations with respect to the payload that it can carry to the space. Payload is the actual satellite which it launches in the orbit, right? Similarly, workload is where the actual work that you are offloading to the computing device so that the computing device can run it successfully. So this is a very brief evolution of what cloud computing is, right? And what exactly is cloud computing, right? And how is it going to change the way applications are developed and managed? And what is this whole lot of hype? I mean, it's no longer hype, it is reality, cloud computing. So probably I should remove that. And what is that I should know to keep up the pace, right? So a simple definition for that is it's a specific computing style where everything from computing power to infrastructure to business applications are provided as a service over the internet, right? So now this is where we'll have to look at very carefully, right? It's over the internet, right? As I said, it needs no major setup, right? It just can be accessed over internet. Anyone and everyone can access it. And as a service. So what is the definition of as a service, right? So let me just take an analogy here, right? So now, I need electricity, right? And all of us need electricity, not just me, right? All of us need electricity, right? In fact, the reason why we are in this session is because of some electricity which is powering the infrastructure which is required to run this Zoom meeting, correct? And your laptops, mobiles. So now, do we produce electricity by ourselves? No, we don't, right? So because we don't need to produce electricity all by ourselves. The reason being, there is a public utility that is available who is taking care of producing that electricity at scale, right? I mean, they're not going to produce electricity just for the sake of one or two individuals, right? They're going to produce the electricity at scale for a nation or for a state, correct? So that's the hyperscale that we are talking about, correct? Because they're going to produce it for an entire state. And then they will distribute that electricity through some mechanism. And if I'm constructing my house, I will request for an electricity connection. And somebody from the electricity board would come and fix a meter and give the connection. And later on, I will install utilities such as appliances and so on and so forth in my house, and I'll start consuming it, right? So now when I consume it, there's a meter that meters my consumption on a daily basis or on a monthly basis, and then it generates a bill saying that, okay, so this month your consumption was 250 units or 300 units, and this is the bill that I need to pay to the power distribution company, correct? So now in this case, this is produced at scale. The key things that we need to notice, this is produced at scale, distributed widely to a broad set of consumers. It is metered and it is on demand, right? I draw so much electricity on demand, right? So now when I'm alone at home, probably I may not need to consume a lot of electricity, right? I mean, I just need to probably use one fan, probably a light, and probably an AC if it's a humid place, right? And to power the other appliances such as TV, so on and so forth. But imagine, there's some event happening at your home. There's a party that's happening at your home. Obviously, during the party time, a lot of guests would visit your home, and obviously you need to, they will have to, be spread across the home. So the consumption of electricity would be higher, right? In such case, you don't worry about it, right? So you just go ahead and start consuming it, right? So probably the difference between the day on the party when you had the party versus a normal day would be probably double, right? The consumption would be double, but you really don't care about it because there is a hyperscale that is available, who's offering you electricity at that scale, and you're just consuming it. And for whatever additional that you consume, you're going to get billed for it and you're going to pay for it, right? So now just apply the same analogy to cloud computing as well, right? So now in cloud computing, providers like AWS, Azure, Google are offering you services which is available at scale, right? So now they're not going to build these services and offer these services for one or two customers, right? They're going to look at millions of customers, okay, millions of people who can use it, right? So that's why it's called an hyperscale. Okay, so now in that process, what they do is they give you the ability to consume the necessary services, cloud computing services, through a broad network access, which is through internet. And they only charge you for the amount that you use, for the quantity that you use, right? So they're not going to charge you fixed price, right? They're not going to charge you. In fact, you can get a $0 bill as well, or you can get a $1 million bill as well, right? Depending on your usage. Now you get a $1 million bill, and suddenly you hit a recession or something happens, or some pandemic of this type happens, and your the consumption of your services go down. You can bring that $1 million bill to probably $1,000 bill as well, right? Overnight. So that is the power of cloud computing. It's very similar to electricity, the power distribution that we were talking about, right? So that's why it's called as a service over the internet, right? So that's very important, and you have multiple different models through which you can do it. And this is a formal definition of NIST. So NIST is called National Institute of Standards and Technology, who defines the standards on the emerging upcoming technologies, and so that there's some amount of standardization that is there in the industry, right? So now this is where, if you see, it's a model for enabling convenient on demand, right? It's a very, very important terminology that you need to understand, because tomorrow, later down the line, you attend interviews and you're asked to explain what a cloud computing is. You can just remember this definition and you can just explain this definition, right? I mean, this is not just only for storage, right? It's not only for storage. This is not only for one particular type of service, right? It's a on-demand network access for shared pool of configurable computing resources across networks, servers, storage, applications, and services that can be rapidly provisioned, right? I mean, you can just provision an compute instance or a storage by just a click of button, and released as well. Rapidly, it can be provisioned and rapidly released with minimal management effort or service provider interaction. You don't need to interact with the service provider like Amazon, AWS. You don't need to interact with them on a daily basis, because everything is available to you in an on-demand self-service fashion, and you just need to consume it and using the console, and you just need to interact with it through a bunch of APIs or through some interfaces or through some applications that you build, right? And what are those resources? Resources can be system infrastructure such as server, storage, network. Applications can be information, it can be business process, right? So now this is the NIST definition. I'll give you this later, you can just go through this. So now, what are the different models of cloud computing? Okay, cloud characteristics, right? I mean, these are the 5 different characteristics that you need to remember. One is it's a measured service, like electricity, it gets measured, right? Similarly, cloud consumption is also measured. Rapid elasticity, it can, as I said, it can scale from $0 to $1,000, $1,000 to $1 million, and then back to $1,000 and $0. It's on demand self-service. It's on demand. It's available on demand anytime you go. It's available. Self-service because you don't need any interaction with the service provider. You can do it by yourself, right? You don't need to, depend on one individual. And it's broad network access because it's available broadly over the internet. It doesn't need any special, networks or any special setup, right? And pooling, it has a bunch of resources pooled. You can just go ahead and start consuming it, right? And the different models are at the bottommost level is the infra as a service, infrastructure as a service, where you just get only the infrastructure, right? When I say infrastructure, you get the compute along with an operating system, plain vanilla, on which you can go ahead and program your applications. You can deploy your applications, right? So that's where infrastructure as a service. So this is for people, who have built applications and who are required, who are wanting some sort of infrastructure to deploy their applications and configure it by themselves. Then comes the platform as a service, which is one level higher, right? Where one level higher of abstraction. So when I say platform as a service, you get a complete platform where you can build your application. You don't need to worry about the underlying infrastructure. You don't need to worry about the operating system, right? But whereas in infrastructure as a service, you still need to worry about your operating system because you need to choose what is the operating system that you want to go for. You want to go for a Windows or Linux or what, right? And if you go for one of these operating systems, you have to decide, how you want to patch it, how you want to maintain that operating system, right? Because you need to keep the lights on for the service, correct? You need to maintain it and you need to operate it as well. Whereas in platform as a service, the cloud provider takes care of the underlying infrastructure of the operating system, and they just give you an interface on which you can go ahead and deploy your applications, right? Some examples are like in AWS, you have got something called Elastic Beanstalk. It just gives you an environment. You build your code, you just deploy the code and start running, it will start working. Okay. So that's one example of platform as a service. And similarly, Azure has also got a few platform as a service offerings. So then comes another level of abstraction where it is software as a service, right? So if you use platform as a service, the application developers can use platform as a service to build applications and start offering them, right? Whereas software vendors, right? Independent software vendors, they're called ISVs. What they do is they build software, they build capabilities that is required, and then they offer it as a software, right? Like for example, right, you have tax filing. Now it's a tax filing season and we're supposed to file the taxes by say December. So now there are different software as a service offerings that are available in the market, right? Such as Zoho, Intuit, right? So these are some of the SaaS providers, who offer you a bunch of these services, right? So you just need to go subscribe to that and start using it, right? Salesforce is another example of software as a service, right? So where you need a CRM application, right? You don't need to build one from scratch, right? So because that entire domain knowledge is all required and it will take longer cycles for you to build it. So that's where you just go subscribe to salesforce.com, register, and you can start consuming the CRM application from day one onwards. Okay. So similarly, you've got multiple things, right? Zoho has got a multiple, models, and in terms of Freshworks has got different SaaS offerings, right? So these are the three different models: infra as a service, platform as a service, software as a service. Now, as we move along, you will see some of these, coming live in action, and you'll be able to correlate with this and make some sense out of it. So then there are different deployment models of cloud, right? So public cloud is like, AWS, Azure, and Google, who are available at the public, right? Anyone can go access it and start consuming it, right? I mean, having said that, it's not that, I'll be able to see your data or you will be able to see my data. There is good level of abstraction and there's good level of security isolation that is there, right? So that's where, you have the public cloud models. So then there's also private cloud. I mean, if you want to build a private cloud within your organization, you can also do a private cloud. And there are, components and that there are suites available for you to technology stacks available for you to build a private cloud of your own. And there are open source tools that are available to build a private cloud. There's also a hybrid cloud, right? So hybrid is nothing but some organizations would want a private cloud but at the same time, they also want public cloud, right? So they want to use a mix of both private and public in a joint fashion. So that's called a hybrid cloud. And again, community cloud is where, this for certain specific community, right, such as governments, right? The government organizations can use, and with a lot more stricter controls, with a lot more data privacy regulations and so on and so forth. That's the community cloud. So, I mean, why do we need cloud, right? I mean, what are the benefits, right? I mean, or rather, what is the driving forces, right? So the first one is data centers, right? So now there's something called a data center, where if you want to host your applications, right, you need to basically deploy them in a data center and design data centers. Data centers will have huge real estate with so many racks, and racks will have multiple servers in it, right? And each server will be associated with some storage associated with it, and you will see like thousands and thousands of racks in data centers, like probably in a hyperscale data centers, like how AWS offers. So now that's where a data center comes in. So now obviously for organizations to manage the data centers, it gets very difficult, because it is not just about managing the servers, it's about managing the cooling, right? You have to manage the cooling of the entire premises, because the servers would generate a lot of heat, right? And you would need to cool it down, right? And obviously the cost is rising. And you also need to supply electricity power to your data center. You need some people, who can maintain the data centers, right? If some servers go bad, they'll have to replace them, repair them, and things like that, right? So which is actually leading to an increased operational complexity and cost. And also explosion of data, right? And there's so much of data that is being generated, right? As usual, probably I may be generating several terabytes of data every year, right? So from that perspective, there's so much of data that gets generated. So eventually, you need a very scalable and cost-efficient model of storing that data, right? So that's where cloud can help you. And then innovation, collaboration. So you need some place where you can actually innovate, right? You can take a quick experiment or a POC, right? You don't need to buy everything from scratch, right? So that's another important model of cloud computing, where if you were to build your data center of your own, then you actually incur a capital expenditure, right? Every business will have some capital expenditure that they will have, right? So that's the capital that they're investing into that business, right? Whereas when it comes to building applications or for IT, earlier in traditional ways, the capital expenditure used to be very high, because they need to lease a place, rent out a place, and they need to build the data center, where they need to buy racks, and they need to buy the servers infrastructure, say from Dell or HP or IBM, and they have to set it up, and they have to maintain it, right? And obviously, when they buy this infrastructure, it has to be an upfront purchase, right? So that's all a capital expenditure. And eventually, those infrastructure would come to end of life in about 3 to 5 years, right? After 3 or 5 years, they will go bad, and you'll have to again refresh them, right? You'll have to buy new set of infra, replace the old ones, migrate the data, and so on and so forth. So all of this is a lot of pain and headache for organizations. So they will only keep focusing on these technology aspects. They'll not be able to focus on actual business outcomes, or on the business model that is generating revenue for them, right? So it's like similar to electricity, right? I need electricity as simple as that. I'll just consume it from provider. I'll pay whatever that I consume. I'm not going to produce electricity of my own. Rather, I will focus on doing something which interests me and which will basically give me revenue as an individual. Correct. So that's where if you see the data centers are usually expensive to set up, and they will incur a lot of capital expenditures. Now, moving from data center to cloud model, you are actually shifting from capital expenditure to just operational expenditure, right? You don't need to invest, you just go start consuming it, and then you only pay for your monthly bills, right? So which is only the operational expenditure. So you're cutting down a lot on the infrastructure cost, on the capital expenditure cost. And again, rising energy and energy cost and green compliance, right? I mean, providers like these, they have a very efficient way of managing power, cooling, and so on and so forth, right? In fact, there are some data centers that are even constructed, some cloud data centers that are constructed under sea, right? So the reason being, the cool water of sea can cool down the data center, right? The compute equipment inside the data center, and you can reduce on the electricity bills for cooling, okay? Because you need to run ACs, right, for cooling the equipment. So now they've even thought about, and it's in fact it's happening even today. Microsoft has got a data center, undersea data center, so that it gets cooled efficiently. And recently they had to take it out, clean the moss that was there on top of it, and then again put it back inside. So, so that way, these hyperscalers like AWS, Azure, and Google, they've got very efficient ways of, managing the energy cost and green compliance. So that way, it becomes. I mean, these are some of the driving forces that companies look at. Benefits, as I said, you are actually going in a pay-per-use model. You're reducing your capital expenditure and you're increasing operational expenditure, and it's all agility and flexibility. So these are some of the terms that all of you should be aware of, right? Because when you attend interviews, they will ask you what is the benefit of cloud. You can say it's reduced cost, increased agility, right? What is agility? Agility is fast, and you make it much more faster, right? And in the current business context, everything has to be much faster, right? I mean, you can't order a cab and wait for 5 hours, right? You order a cab and you can only wait for 2 hours. That's our patience levels today, right? We don't wait beyond 2 minutes, right? We order a Ola or Uber cab and we just wait only for 2-3 minutes. If the driver doesn't turn up, we cancel it and look for another one, right? So now, from that perspective, the consumers have become are demanding these days, right? And obviously the businesses will also have to keep up to the expectations of the consumers in terms of agility and flexibility. Then it's more greener, we spoke about it. Then more mobility, right? I mean, mobility is very important. So now you build a mobile app on cloud, on AWS, and you host it on AWS. Anyone can access it, right? I mean, that way it gives you, it doesn't need any special network setup. You are just exposing it over internet, and anyone can access your mobile app. Like, you can download it from App Store, Play Store, and create an account for you and start using it and start consuming the services. You can access the information from anywhere. And what are some of the benefits with traditional versus cloud computing? Resource provisioning. When I say resources are nothing but the compute resources, storage, and so on and so forth. Right? It used to be weeks in the traditional way, whereas in cloud, it's just in minutes. You will see it, right? When you start provisioning it, you will see it. Scalability, and you can add resources manually, but here it's about on-demand scalability. Delivery model, you buy the assets. The assets will turn into liability over a period of time, right? But here you just buy service. You don't worry about asset liability. You don't need to worry about your P&L model, right? And you don't need to show all of this infrastructure in your P&L books, right? You just need to buy the service and start consuming the service. Like, again, I'm going back to my favorite power electricity model. You don't buy any of these assets, right? You just buy some wires, some electrical connections, and you just buy some the meter. That's it, right? That's it. You don't even buy the pole that is outside your house, right? So that's all set up by the power distribution company, right? And you don't need to really worry about it. So all of that. So you're just buying a service. You're just buying a service called electricity, and you're paying for what you use. In terms of flexibility, it is traditional procurement model, but whereas in the cloud computing, it's all about self-service. You just self-service and you kind of do it by yourself, right? And here, cost, it's every year you incur additional capital expenditure, whereas in cloud, it's about pay-per-use model. You just pay for what you use. And again, these are three different models, as I said earlier. Infra as a service, where you have Amazon EC2, which offers you a virtual machine on cloud. Okay, platform as a service, as I gave an example of Amazon as well. It's called Elastic Beanstalk, but Google has also got a Google App Engine. Azure has got some Azure app services and things like that, where you can just develop code directly on these platforms. So you don't need to worry about the underlying software platform, hardware, and things like that. Software as a service is completely on, you just take Google Apps, right? You need Word, Excel, PowerPoint, and all of this. You can just go for Office 365, right? You don't need to install these softwares. You just go procure the subscription. That's it, you're done. Similarly, Google Apps, it has got a lot of applications, right? Google Docs, Google Sheets, Google Drive for storage, productivity applications, right? So you don't worry about anything. You don't worry about infra. You don't worry about platform. Everything is available for you. So, and this is how, if you see, this is IAS. PaaS is PaaS plus IAS. PaaS is SaaS plus IAS. But you see, PaaS and IAS would be abstracted completely from the end user. And again, there are some examples of more details on what is the infrastructure service. I'm not going to go too deep into this, right? I'm just going to skip some of these. Maybe you can just read about it. And virtualization is another important concept. I'm sure a lot of you would have learned virtualization as part of your college curriculum, right? Again, virtualization is very, very important because virtualization is literally the technology that, I think somebody has to go on mute, please. Yeah, virtualization is the technology that is literally enabling us to isolate the underlying hardware and give a bit of hardware to the consuming applications that are there. Sai Krishna, can you please mute? Somebody is on unmute. For mentors, if you have just access to mute, kindly mute. Yeah, and so there are some benefits and challenges, and there's so many IaaS providers that are there: AWS, Azure, Google, then platform as a service. Right. In this case, if you see in platform as a service, you've got infra. Then you get a complete development platform. You only get a development platform. You don't need to worry about the rest of it, right? Underlying. And in this case, in power distribution, I really don't worry about what grid they use, what technology they use, nothing of that sort. And again, in software as a service, it's just about offering the complete software like business applications, Gmail, Salesforce, Facebook. Okay, so let me just take a pause here, which we just left with about 5 more minutes. So see, the key takeaways that I want all of you to remember is cloud computing is a revolutionary technology that is offering services, to in the technology space, right? So where you don't need to worry about anything. You just go subscribe to that and start using it and start building great things on top of it, right? And it's all on pay-per-use basis, and it covers pretty much all the aspects of technology, such as it can offer you servers, it can offer you storage, it can offer you platforms, development platform for you to build applications, or it can also offer you, in any technology space, you name it, cloud will have it, right? For example, IoT, right? You have IoT offerings on cloud, IoT services on cloud. You have mobile, right? Mobile offerings. You have mobile. You have ability to build mobile apps very quickly on cloud and post it on cloud, right? And you have AR, VR, virtual reality applications. So you can build virtual reality and augmented reality on cloud, right? So that's pretty much what a cloud gives you, right? But I'll just show you a few more things which you can read out today, and then what we can do is we can start exploring the AWS platform from tomorrow. I'll share so all I want you to do today is to go to this URL, aws.amazon.com. Okay, and then start browsing through and start reading to whatever extent that you can do. Just go through this. This is the home page, right? And if you just hover on this products, you will see these are the various different products that AWS offers. It offers broad, as I said, you name it, we have it, right? Right. So it has got analytics, it has got blockchain, it has got compute, contact center, containers, database, game. You can build games on AWS, Internet of Things, machine learning, artificial intelligence, right? Robotics, you can build robotic applications, satellites, right? In fact, AWS has got a service called Ground Station, with which all the technology and compute that the components that is required for you to set up a ground station, you can take it as a service. And if any of you are passionate about space exploration, and you can use this AWS ground station service, and you can start building out your rockets, satellites, and serverless storage, multiple storage options that are available in AWS, right? VR, AR, right? So just go through some of these, right? And you can start exploring some of these. Maybe you don't have to go too deep. Maybe we still need to I still need to introduce you to some of these. But out of curiosity, you can always go through this, right? And you can watch some videos, right, on AWS, on data centers, right? I mean, if you go to YouTube, you can just watch large-scale data centers. Large-scale data centers, right? Yeah, or you can just say Amazon data centers. Yeah, you can just watch this video, right? What happens inside Amazon's massive data centers, right? And how big is Amazon data center? You can just watch some of these videos, right? And start going through some of these. That's the assignment for today, right? And I will wrap it up with this. And tomorrow, I will start with explaining the curriculum for AWS. And then I'll also tell you how to set up your own AWS accounts. All that you need is a debit card or a credit card. I mean, you can use the free tier of AWS. If you go to the pricing, you can just go through this as well. AWS free tier. You can. So I request all of you to read this today, right? I mean, when you go through this aws.amazon.com, the portal, please go through this AWS free tier. So that's a homework that you need to do today and understand how the free tier works. Okay, and tomorrow we will create a free account, right? I'll show you how to create a free account. You can create a free account, and but before that, you need to get a complete understanding of what free tier that AWS gives. AWS gives you free tier for beginners, for learners, or to people who want to do experimentation for 1 year, right? So it's a 12-month free, so which will be good for you to make use of. It is more than enough for you to do your lab activities and do your hands-on activities. Okay, all that you need is you just need a credit card or even a debit card would do. I mean, AWS is not going to charge you unless and until you go overboard of the free tier. Anyways, I will explain all of this, but just read about this today, and then we can regroup tomorrow morning at 9 o'clock. So please be sharp for tomorrow's session at 9 o'clock, because we're going to do some important things. And if any of your friends have missed it, please do inform them to participate in tomorrow's class, and then we can get started with the curriculum and setting up of your free AWS account tomorrow. Okay, I will share this deck. Okay, Sai Krishna, probably I will share this with you. Maybe we can put this in the Google Drive for students to access it.
Sure, and I will do. Thank you.
Okay. Okay, all right. And I'll just take leave now, and I'll see you all tomorrow at 8:58.
Thank you so much. I think you have a hard stop now. If you have any questions, I'll park it for today, and I'll ask you tomorrow.
Sure, sure.
You can disconnect now. Thank you so much.
Sure. Yeah. So just go through some of these, and more importantly, just open AWS.